Hello and welcome to the Geo 7.3 video. So in this video, we're going to be talking about how to prove that a quadrilateral is a parallelogram. In the last video, you learned about different characteristics about parallelograms, what we can conclude about their sides, their angles, and their diagonals. And now we're going to talk about how to prove that a quadrilateral is a parallelogram. So we're first going to reference your flow chart. So you want to have your flow chart out. And we are going to still be talking over here about that parallelogram box. We'll get to the other stuff later on in other videos. So when you look at your parallelogram box, hopefully from the last video, you should have the information filled out about sides, angles, and diagonals. And now we're down here talking about ways to prove quadrilaterals are parallelograms. So we can use any of these characteristics above to prove that a quadrilateral is a parallelogram. For example, if we were given opposite angles are congruent, I could then conclude that that quadrilateral is a parallelogram. In addition to these 5 up above here, I can also use the fact that if I am given one pair of sides is congruent and parallel. So if you look in this diagram here, I know it's kind of small. We've got one pair of opposite sides. So they are parallel and congruent. I have those arrows and the tick marks on these same set of sides. So let's write that down. One pair of sides is congruent and parallel. So instead of both pairs of opposite sides being parallel or both pairs of opposite sides being congruent, I have one pair of opposite sides being congruent and parallel. So once you have that written down, let's go ahead to your notes worksheet where we're going to be going over examples. So in your packet now, let's go ahead and look at example 1. It says in quadrilateral WXYZ, measure of angle W is 42 degrees, measure of angle X is 138 degrees, and measure of angle Y, sorry, this should be capital, is 42 degrees. Find measurement of angle Z. That's a lot of information, and I am a visual person, so I'm going to go ahead and draw out this quadrilateral. Four-sided polygon, I've got W, X, Y, Z. Notice you have to go in clockwise or counterclockwise, right? W should be next to X and so forth. So I have the measurement of angle W is 42 degrees. I have X is 138 degrees, and I have Y is 42 degrees, and I need to find the measurement of angle Z. Okay, well, let's call Z X. So I know 42 plus 138 plus 42 plus, actually calling it X is kind of confusing. Let's call it just measurement of angle Z is equal to, and if I somehow knew what all 4 angles here added up to be, I knew what my equation would be equal to. Well, if we think back to 7.1, the sum of the measures of interior angles, a quadrilateral is going to be 360 degrees. So I know all 4 angles added together are going to be 360 degrees. And now we just need to solve this equation. So let's combine like terms here. 42 plus 138 plus 42 is going to give me 222 plus the measurement of angle Z is equal to 360. Subtract 222, subtract 222. And I have measurement of angle Z is equal to 360 minus 222 degrees, which will give us 138 degrees. Okay, that was part A. Find measurement of angle Z. I'm going to go ahead and label that 138 degrees. Part B asks, is WXYZ a parallelogram? Explain your reasoning. Okay, so this is where I'm looking for one of these ways to prove that something is a parallelogram. Since I am given information about my angles, I'm going to look down here and I'm thinking, okay, opposite angles are congruent. Could that be true? Yes, when I look at this diagram, my opposite angles are congruent. Both pairs of them are congruent, right? W is congruent to Y, Z is congruent to X. That in itself is enough information to prove it is a parallelogram. So yes, both pairs of opposite angles are congruent. And once we've proven that it is a parallelogram, I can then conclude all those other properties about parallelograms are true. We don't really need to do that for this problem, but that's just something good to know. All right, looking down below at example 2, it says find the values of x and y that makes the quadrilateral a parallelogram. So we don't know that it's a parallelogram, but I want to find the values that make it one. And I see when I look at my expressions for x and y, they're on my sides. And I know that my opposite sides are parallel and they're congruent. Well, parallel is not going to help us, but the fact that my opposite sides are congruent will help me. So I know PS is congruent to QR and SR is congruent to PQ. So I have to be really careful to set the opposite ones equal to each other. So SR is opposite from PQ, so those two sides are congruent, and PS is opposite from QR, so those two sides are congruent. So I'm going to have two equations. I'm going to have 2x minus 1 equals x plus 9, and I'm also going to have y equals x plus 7. Well, I want to solve the equation with just one variable and then use that variable to plug into my second equation. So to solve my first equation, I'm going to subtract x from both sides. And I get x minus 1 equals, these cancel, 9, plus 1, and x equals 10. Okay, and then my second equation, I have y equals x plus 7. Well, good news is I already solved for x, so I can substitute that in. So I have y equals 10 plus 7, and I have y equals 17. So I solved for x and for y. And now I need to just think through my explanation. And this is exactly how I set up my equations in the beginning. I knew that my opposite sides were congruent, so I could set those equal to each other. So my reason is because opposite sides are congruent. So those values for x and y will make my opposite sides congruent, which makes this quadrilateral a parallelogram. Example 3, we are going to save later for after the video. And then example 4, we're going to do together right now. So this asks us to explain why each quadrilateral is a parallelogram. So again, you're looking at your chart and you're thinking about all those characteristics can prove it, along with having one pair of opposite sides congruent and parallel. All right, let's first look at example A here. I see I have 30 meters and 30 meters. That means the lengths are the same. I can put tick marks to show that they're congruent. And I have that triangle, which shows that those sides are parallel. So now I just have one pair of opposite sides that is congruent and parallel. And sure enough, that is a way that we wrote down to prove that a quadrilateral is a parallelogram. So going back to my problem, I can say that it is a parallelogram because one pair of opposite sides are congruent and parallel. Sweet. Let's look at B together. So B, we're given 7 inches and 7 inches. We know those are congruent, and we're given 5 inches and 5 inches. I'm putting 2 tick marks because this is a new pair of congruent sides. So I'm thinking, okay, I've got 2 pairs of congruent sides. They're opposite from each other. Sure enough, when I check my chart, opposite sides being congruent is a characteristic that will prove that a quadrilateral is a parallelogram. So both pairs of opposite sides are congruent. And lastly, when I look at part C, I see I'm given information about my angles. I see my opposite angles of 65 are both congruent, and my opposite angles of 115 degrees are both congruent. So that means that this is a parallelogram because both pairs of opposite angles are congruent. Notice I also could have used the fact that I have 4 pairs of consecutive interior angles being supplementary, right? And that's kind of what was shown in the last video. Here's one pair of consecutive interior, another pair, and another pair there. And we don't necessarily need all of those to show. We would just need to show that both pairs of opposite sides are parallel using those consecutive interior angles. But really, it's just easier to use the fact that both pairs of opposite angles are congruent. All right. And then the last example is example 5. And it says to show that the quadrilateral with vertices of A at -3, 3. Let's go ahead and plot that. -3, 3. There's A. B is at 2, 5. There's B. And C is at 5, 2. And D is at 0, 0. And we are to show that this quadrilateral is a parallelogram. And explain how it is a parallelogram. Okay. Well, when I have these different coordinates and I have my quadrilateral plotted, I can actually find a lot of information about the sides and about my diagonals. So if I just think about the major characteristic of a parallelogram, the fact that both sides are parallel, I can actually show that based on the coordinates that I'm given. So my goal here is to show that both sides are parallel. And if you think back to chapter 3, hopefully you remember that parallel means that they have the same slope. So what I need to do is show that segments AB and DC have the same slope. And then I also need to show that AD and BC have the same slope. Okay, let's first start by finding the slope of AB. Remember that I can just count when I have a graph, so I can just count my rise over run. So from point A, I go up 2 spaces, and then to the right, 1, 2, 3, 4, 5. So my slope is going to be 2 over 5. And then my slope of DC, M stands for slope. If I start at C, I'm going up 1, or if I start at D, I'm going up 1, 2, and to the right, 1, 2, 3, 4, 5. So again, 2/5. Since they are the same slope, this now shows that these two segments are parallel. Let's show that the same is true for AD and BC. So the slope of AD, if I start at point A, I'm going down 1, 2, 3. Since I'm going down, this is in the negative direction. And then I'm going to the right, 1, 2, 3. So -3 divided by -3 divided by a +3 will give me a -1. And then my slope of segment BC, if I start at point B, going down 1, 2, 3, and to the right, 1, 2, 3. So again, -3 divided by 3, which is -1. And again, since they have the same slope, we just showed that those two segments are parallel. So just kind of as a concluding statement explanation, both pairs of opposite sides are parallel, so it's a parallelogram. I know it seems a little bit redundant that I have to write out the slopes being the same, but think of this almost as like an informal proof, right? We have to be very explicit to show they have the same slope and are parallel. We could also use the opposite sides being congruent or the diagonals bisecting each other. If you are curious about that, be sure to ask your teacher because there are other ways to show this. But this is definitely the easiest. And that finishes up our 7